Hello, Mr. Newman. Here's the video I promised to put for you. I just did my signature sign-on for my students because they seem to get a real kick out of it. Okay, now I'm going to do a real simple one. Like, I know, Jeff, both you and I can solve this one, factor it in like no time. But I'm going to show you how it works, and then I'll demonstrate it over there. Okay, so in this case, the lead coefficient's 1. Well, 12 times 1 is 12. So what I'm going to do is I'm going to list factors of 12. Okay. Now, obviously, your kids who know their factors really well can probably do this in their head. I wouldn't normally teach this one this way. The level 2 kids, I teach it. The kids who get it a little bit better, I show them this way, but then I point out the quicker way, and I'm hoping that they'll catch on. Okay, and like I said in the text, it alleviates, all the different types of factoring. Okay, so I'm going to need to rewrite this middle coefficient, this negative 1x. I'm going to need to use two factors of 12 to do it. 12 is the product of a and c, right? If I'm thinking quadratic formula. Okay. And I'm going to need to subtract because the 12 is negative. So I'm going to write x squared, and I'm going to write a minus 4x, and a plus 3x, and a minus 12. And now I'm just going to factor by grouping. So I'm going to group the quantities, always grabbing the sign, stick a plus in between there. Factor out a GCF, I get an x. I'm left with an x minus 4. Okay. Factor out a GCF here, it looks like it's going to be a 3. I'm left with an x minus 4, and I will GCF one more time because x minus 4 is a common factor to both terms in the equation. So I'll factor out an x minus 4 from both parts of the sum, and I'll be left with an x, and then here I'll be left with a plus 3, and there you go. And I know you're thinking, well, I could do that so much quicker. Absolutely, but our kids don't seem to have the number sense that you and I have, or that they had 5 or 8 years ago. So this is why I'm choosing to do it this way, and they really seem to like it. They can follow the method better, especially when I teach them. First of all, I teach them how to GCF, then I teach them how to group, then I teach them how to group a trinomial like that, and they seem to like it. I can't remember who it is. I always try to give props to the person that showed me, but one of the teachers at one of the other middle schools said they tried it and they loved it. And so I went home that summer. I had already taught factoring, and I went home and tried it and worked through it, and man, I started to like it. It really started to grow on me. So how would we do one like this? Well, I'm just going to multiply 10 times 12, and I'm going to get 120. Okay, and I'm going to need factors of 120 that subtract. Now, I don't have to list all the factors. I mean, I can be smart about it. I know 12 and 10 aren't going to work because they're not going to subtract to get negative 14. All right, but I'll just go ahead and list them all. Okay, obviously these are way too far apart for me even to really consider. There's nowhere near 14 apart, as you know. Okay, I'm what, 26 apart there. I'm getting closer. Oh, excuse me. 5 and 24, I think. Well, now I'm getting close. I'm at 19. How about 6 and 20? Ooh, those are 14 apart, aren't they? Now, I need to subtract, so I usually have the kids write down the subtraction problem. They need a negative 14, so they can write down 6 minus 20, or they could write negative 20 plus 6. Either way, so they get their signs right. Then they come over here, and maybe they'll write it like this, and then minus 20. Oh, I lost my x there, sorry. Minus 12, okay? I'm going to rewrite that so it's spread out a little bit better. Okay, 6x minus 20x minus 12. Now, they could have put it in either order. It wouldn't have mattered. Okay, so of course we're ready to group. They teach them to always grab the sign when they're grouping. Okay, I'm going to factor out a GCF here. It looks like it's going to be a 2x, I believe, and that'll leave 2x times the quantity of 5x plus 3. And then here I'm going to factor out a negative 4, right? A negative 4. Okay, and a 5x minus, plus 3. Okay, now I missed the GCF to begin with, but that's okay because it'll still work out. That's a 4, by the way. Okay, so I have a 5x plus 3. That's a common factor. So I have a quantity of 5x plus 3. Okay, I'll be left with a 2x minus 4. And then, of course, there's a GCF hiding in here. I really should have pulled that out at the beginning. So I have 2 times 5x plus 3 as a quantity times x minus 2, and that would be the complete factorization of it. I really like it. From my experience, what was happening, I really considered myself to be excellent at teaching factoring. My students, if I throw out names like a Ben Krieger or, guys from that long ago, Amy Olszewski, Veronica Huber, I don't know if you had any of those students, they really tore it up and got it. And nowadays, with, the shift that the district has gone to with the OAA, fortunately that's ending, but they really lost their number sense. And so the old methods of factoring that we were taught with are very difficult for them because they don't have the same base knowledge that you and I had or those other students I mentioned had. And so when I tried this, it made sense to them because, I GCF'd and I GCF'd and then I GCF again. So when I teach factoring, obviously I teach GCF. Okay, I teach grouping. And then I teach grouping of trinomials. Okay, and of binomials. I mean, you can do something like this with the difference of perfect squares. Then what I do with the special ones, like difference of perfect squares and perfect square trinomial, I make those offshoots. And so I don't necessarily do whole lessons on them. Perfect square trinomials and difference of perfect squares. Anyway, I kind of do them as an enrichment for the kids who really get it and have that number sense that you and I know. And what I find is, if a kid has this, let's see, 9x squared, let's take a plus 25 over there, and so what are we talking, 30? Yeah, 30x. Okay, well, they won't recognize that is the a perfect square trinomial. I want them to recognize them. It is important to recognize them. They can still factor it, okay? And it's way better than the way I used to do it, where they would go 1, 9, 3, and 3, and then 1 and 25, and 5 and 5, and then sort of guess and check their way to say, hey, I'm going to multiply 3 times 5, and then I'm going to multiply 3 times 5. Okay, and that's going to get me a 15, and that's going to get me a 15. If they're both negative, I get a negative 30, so now I can factor it. I mean, I like that way if they have number sense, but the students just don't seem to be coming with the number sense. And so I believe they have an easier time. 925s, 425s would be 100, so we're talking about 225. Okay, and then of course I list the factors of 225. And I need to get a negative 30. I need to be adding them all. Hey, that's 15 and a negative 15. And so then if I go 9x squared minus 15x minus 15x plus 25, and then I do my grouping thing. And you know what, you can go ahead and practice. That'd be a good one to practice on because you know the answer. It'll come out easy. But another reason I like it is it gets them to think about negative 30x in a different way. Think about it as, negative 15x and negative 15x. And you and I both know that's so important to be able to see the things that aren't there, to be able to manipulate something of equal value, use something of equal value in the place of something else, which will make the problem easier to deal with. Anyway, I hope this makes sense to you. If not, give me a call and we'll hook up for a few minutes, maybe after Boys Club or something Tuesday. Hopefully you can make it. And I'll talk to you later, buddy. Happy Easter. Bye-bye.